Let's take a look at a topic. For example, at this time in this network, I got an admin address. That is, an address segment is given. Address range. Let's say 194.2.3.0. Such a network segment. 24-bit mask. Now it's time to assign it to 4 departments. These 4 departments are different departments. Then I want them to belong to different address segments. Now we have to do an address division. Assigned to 4 different departments. The first is the project department. Suppose there are 58 people in the project department. So for these 58 people, we're going to assign it an address accordingly. The next one is the RAND department. More people in RAND department. 100 people. The address is something we'll fill in a moment. Next is the marketing department. The marketing department assumes 27 people. There's something called a gateway involved. Since we haven't gotten there yet. So when I talk today, I won't count this address. But I have to design the question. I'm going to design it. Okay. Suppose there are 15 people in the finance department. We're going to make a division. As a web worker, now you have to plan an address segment. First, I'll teach you what to do when you're doing something like this. In fact, in the future when really planning the project, by default some subnet masks are used. Mask calculator can calculate. But let's follow normal way of planning. When you do address planning, planning must be made for the department with the largest number of people. That is, find a maximum value. It must be ensured that a subnet is now sought first. Is now a Class C address segment. Make sure to ask for a subnet first. And this subnet is okay. Satisfy the situation with the largest number of addresses. Now there are 100 people in the RAND department. Therefore, it must be allocated to the RAND department first. Otherwise, after planning the address, divide it into different small subnets. Eventually you will find 100 people in the RAND department can't fit in. This will not work. It's like you are cooking for others in the cafeteria. If you want to make sure everyone is fed, then you should let the big eaters come first. Small eaters in the back. It has some headroom. If you let the big eaters come later, that might be their turn. Leftovers are not enough. So, this address segment itself must be planned. Just put. Sure is reasonable. Must be allocated. But if these departments with a small number of people are allocated first, it is very easy to cause too much stuff allocated to them. Make sure. Assign to the person with the most number first. Satisfy the situation with the largest number of addresses, or the most seen. Once the address is assigned, can no longer be used by others. Notice. Can no longer be used by others. A network segment. If I assign it to the RAND department, I can no longer use it for other people. Because we have to isolate different network segments. Like you cut a cake. After you cut it, give it to someone else. You can't say, others seem to have some left over. I have to come back and share it with another person. This is not possible. That's for us on the project. That doesn't meet the current overall requirements. Cannot be in a network segment. If there are a few addresses left in the network segment, I can still use it for you. It doesn't make sense to divide the network segment. So once the address is assigned, can no longer be used by others. So let's solve this problem now. We now need to know what the addressable addresses are. Distribution has not started yet. Then the address that can be allocated. must be the most, is 194.2.3.0, 24-bit mask. We first give the RAND department, because there are too many people. In the RAND department is 100 people. If a department has 100 people, then the default subnet to satisfy 100 people. So how can you be satisfied? This requires more addresses. Need more than or equal to 100 addresses. Can you understand? Since now every variable bit are 2 cases, then it is 2 to the power of x. Please pay attention. 2x squares are fine by themselves, but you have to consider. Now it's time to calculate. Each network segment has 2 addresses. Network address and broadcast address. So it is equivalent to need. Subtract these 2 addresses. X stands for variable. That is to calculate. How many host bits are there now? How many network bits? But after subtracting these 2 addresses, must be greater than or equal to 100. I want to emphasize to you. We'll learn something later. Gateway. By default, when we go to assign addresses to enterprises, you have to take into account the problem of assigning a gateway to each network segment. Since we haven't learned about cross-segment, there is no problem with subtracting 2. After subtracting 2, the address is now available, but only to ensure that the internet can communicate with each other. In the future, once we are going to access the extranet, or access across network segments, must have a gateway address. As for the gateway, we haven't talked yet. So even if it is -2, even if you subtract 3 here, plus the gateway can also be used together. I'm just giving you an introduction. Okay. Let's start by subtracting 2. This x is what we call the host bit. 100 people are 100 hosts. That x is actually the host bit. So let's calculate what x is. Logically speaking, before subnetting now, the host bits are 8 bits in total. Address that can be assigned at this time is such an address. Okay. Is 7. But everyone will find, if it is 2 to the 7th power, it's more than 100. The rest of the address is wasted. Please pay attention. We use this method when calculating. Often it is not possible to do a tight fit. Not exactly calculated. So, it is normal for us to set aside multiple addresses. So now 7 host bits are actually used. That means network bits need to be borrowed. It turns out that the network bits are 24 bits. Borrow 1 now. At this time. Since I've borrowed. Subnetting for sure. Divide into 2 subnets. I'll just tell you one of the above. The first one is 194.2.3.0. Don't look before. Just look at the one behind. Originally this bit was 0. Now divide 1 more. Then this one is 1. This is the one who borrowed. Then for the subnet. Except for the one you borrowed. The last 7 bits are the host bits. All set to 0. This is what is calculated now. The above calculation should be 0.0. This one below is 0.128. That is 194.2.3.0. Mask is 25 bits. We're taking a borrow now. After borrowing. Actually, there have been 2 changes in this one. We will put such an address segment. For RAND department. I'll mark it for you. Okay. This is the subnetting we do. Equivalent to divided 2 subnets. Next we're going to start assigning. I plan to assign to the RAND department. Above this 194.2.3.0. and is a 25-bit mask. Let's calculate the network address of this network segment. 194.2.3.0. This is its web address. 25-bit mask. Its broadcast address. That is, all the following bits are set to 1. 255 minus 128 is 127. Change this 0 to 127. Okay. That is to say, we now put such a network segment assigned to RAN D department. So, we can fill this network segment to the RAN D department. Then let's look down. When I now divide this network segment to it, in fact, this network segment is given to it. So what is the address that can be allocated at this time? I just created 2 subnets. Then I used one of them for the RAN D department. Then now, what are the addresses that can be assigned to other departments? Okay. There's only one address left, because of the 0.025-bit mask, already used by others, can now be assigned to other departments. That's all that's left. In the future, when we calculate, if you do subnetting again, you can only move back from its foundation. Okay. The first part is actually the same. You can follow my logic after class. Then do the math yourself. First to the project department, to the marketing department, to the finance department. You look at the process between them. At last, we can definitely figure it out. That is to say, what we're talking about as a whole. Variable length subnet mask. Let me stress again. According to us, ABC classes are called classed. Such a mask has the form 8 bits respectively. 16-bit, 24-bit mask. If according to such a mask, Class C must have only 8 host bits, then the default is 254 addresses per network segment. You will find these departments add up to 254 addresses are enough. 200 people in total. That explains. If there is a Class C address, 200 people are enough. But now if you don't do subnetting, that's not enough. Because I want them to be on different network segments. But if you don't subnet, that by default, these 254 addresses must be in one network segment. So now there is only one network segment. 254 addresses. 24-bit mask. There is really only one large network segment. It's called the 194.2.3.0 network segment. That is to say, the first 3 are fixed. This is the network bit. 254 addresses in one network segment. For RAN D department use only. Or only available to the marketing department. Other segments have no address. You want the address to be enough. Also wish they were in one segment. No subnetting yet. This is impossible. That's what we mean by subnetting. Now also in a large address segment. But due to subnetting, we can do it both to accommodate all people. It can also be done that they are in different address segments. That's the point of subnetting. We subnet. Not just for calculations. You need to know this scene. Okay. Finally, let's briefly talk about classless interdomain routing. There will be a new format here. Classless interdomain routing. VLSM we talk about. It is the network borrowing from the host bit. We can put a network segment into multiple different subnets. For a large community, make some logical divisions. Each subnet corresponds to an address range. Eventually these addresses will be applied to the network. Means this. Now, everyone can see It summarizes the network segments on the right. Did you discover it? Classless interdomain routing and VLAM is an opposite technique. The network segment itself is a 24-bit mask. It is changed or notified. Finally made a summary. Aggregated into 22 bits. Classless interdomain routing is called CIDR. It has an alias called SuperNet. What exactly does it mean? I'll draw a picture to explain. We now do a subnetting. Look, here is a device. In this device, I now segment the network. Two different subnets. For example, it's two divisions of a company. Left is 192.168.1.0 25-bit mask. Right is 192.168.1.128 25-bit mask. Actually, it was originally the biggest word. Should be 192.168.1.0 24-bit mask. I have now subnet. I'll test everyone first. If a data comes now, this data is 192.168.1.100. Then please, is this data sent to the left or to the right? This is a very basic question. Okay. Hair to the left. It's covered by this address on the left. When data is forwarded, it must be according to different subnets. To forwarding address. Because it belongs to the left. So it must be a left turn. But you will find, for this picture, now it's just a borrowed one. Borrow a bit to divide two subnets. Borrow another. Divide two subnets. If you borrow 6, that is, the mask becomes 30 digits. Actually, I divided 2 to the 6th power of subnets. 64 subnets. We are exaggerating. I divided 64 subnets. It is equivalent to the original network segment. Can be divided into many network segments. Each network segment contains a different address range. If there is a data in the future, also into this device. Data forwarding. But we have divided so many network segments here. Of course, the interface of the device is not enough. So I'm just an exaggerated rhetoric. We have divided so many network segments. If there are too many network segments, I want to forward data. More information to unlock. More entries on the device. To match the data. Because there are too many network segments. Different network segments are different routing entries. To match. Then you will find more matches. This is equivalent to, originally, I was going into a neighborhood to find someone. This area is divided into two parts. I can find someone directly from this area. Either go left. Either go right. Divided into A-B buildings. Later, the district was divided into 64 districts. Then I'm looking for someone. I also need to confirm one by one. But if everyone sees, will be slower. I might as well decide whether to go left or right. After entering a more accurate tour. It's just like you want to go from area A to area B. Actually, you can fly. You can also take a car. Usually, a general route is determined first. Then step by step. In fact, relatively speaking, this will transfer data faster. So we can now let go of the perspective. Don't think of it as a community. You imagine the world. A network of all things. We have now subnet. That in the large network environment. Of the entire network. You think about it. What will data forwarding look like? It will be slower. That is. Now there are more subnets. It's true that you can save IP addresses, but brought a new problem. That is, the efficiency of forwarding will be reduced. So we're thinking, when this data is forwarded, can I see a little less information? Can you forward it a little faster? Let's look at this picture. As a company, I will give you a brief introduction. It says LAN. It stands for Local Area Network. This is an internet. That is, between us. To advertise some routes. Check back later. To forward the corresponding data. Let's ignore its specific address format. Why do devices and operators advertise routes to each other? These you will learn when you come to the NP stage. Let's just talk about technology for now. Stop talking about the scene. Because now, in terms of some technologies of IP addresses, now a network is divided internally. 1.0, 2.0, 3.0. We can make a division. So how exactly do you calculate this? Let me tell you briefly. As the internet, there will be a lot of users connecting with it. For example, this is your company. You have to make some announcements with the operator. That is, devices you want to connect with them on the internet. Make some announcements. Your company notice 4. Another company announcement 4. Suppose there are 20,000 companies in region A. That's 80,000. Although the final announcement is not a single device, but it is also a large network of operators as a whole. Too much information on the internet. As for the operator, to forward the corresponding data to you, I don't care how to get to this device. Either to 0.0, to 1.0, or to 2.0, or 3.0. Actually, go through this router. So I don't care at all whether it will reach the device precisely, as long as it is guaranteed. Now traffic can go to this exit. That's it. As for the fine division at the back, just forward it. It's like a school. In that school, this internet assumes the principal. If this is the head teacher, behind this is a student one by one. For the principal, it doesn't really need to know where the students are seated. Just need to know which class are they from. Just ask the head teacher. Then let the head teacher find the students. The principal has to deal with a lot of things every day. There is no need to record in which classroom and where in the school each student sits. The principal only needs to know which class the student is in. Find this head teacher. The head teacher can find students for the principal. That's what I mean. For operators, it is connected with a lot of users. So, each user will have information to interact with. Then finally, operators don't need to know everyone's precise information. Just make sure that the business can be normal, covering the current range. When the operator announces to the outside world, we are nothing but hope, the operator's traffic can return to the internal network. So just make sure can interface with this export device. Traffic will be able to come down through this device in the future. We can now put multiple small subnets. Use a larger network scope to generalize. Then optimize the overall appearance. That's what I mean. So for the device, as long as future traffic can match such a route, be able to direct traffic to such an outlet device, it can perform more precise forwarding. This is what we call CIDR. So how exactly is it calculated? I can also briefly tell you. I'll tell you how. You can do the calculations by yourself after class. It is calculated in the same way as VLSM. First convert it to a binary. After turning You will find they have a very large number of digits in front of them, all the same. This is a total of 4 groups. You do the math after class. The preceding digits are almost always the same. When you compare them, continue to compare until a certain person is different. Stop from that one. Then set all the following values to 0. Then it is calculated that this. The first step is to convert all the network to binary. Then start from the first. Compare later. Until the comparison to a certain behind is different. The previous requirements are exactly the same. Stop all from this one. Then all the following values are 0. Then the front is the network bit. Behind the host. It is the large network segment advertised. This is what we call classless interdomain routing. Sometimes it will have some other situation. I leave you with an extended knowledge. But it doesn't matter. For example, now add a network segment. 10.24.4.0. 24-bit mask. So you will find, when summing up 5 of them at the same time, some problems will arise. You will find that a large network segment is counted. But this network segment will cover more. For example, it will cover 5.0, 6.0 and 7.0. Sometimes advertised routes. It's not so rigorous. 22-bit mask. Just enough to cover all the changes. It just represents from 0.0 to 3.0. Such 4 network segment ranges. But if you add a network segment, such as 4.0, aggregate them together. In the aggregated network segment, there will be several other network segments. It's just a few more small network segments. What if this happens? If this is what I said, just sum up the 4 of them individually. Then put this extra. Just announce it separately. There is no need to bring them all together. Finally, to sum up, we learned about IP addresses today. Then learn the last 2 techniques. VLSM and CIDR. We learn VLSM to make the mask longer. Learning CIDR is to make the mask shorter. I'm going to subnet. I'm going to merge these subnets again. And then announce. You might think it's contradictory. First, these 2 technologies, their scenes are different. Is not conflicting. We can take a company as an example. We as a network engineer. To plan the network segment reasonably for the company. Equivalent to. You want to assign different network segments to different departments of the company. We won't talk about switching technology today. In terms of simply dividing the network. Segment network. Then VLSM is used for network segmentation. Is used to divide subnets. Isolate traffic on different network segments. CIDR ends up just working on routers. To reduce the number of appearances in the routing table. Optimized data forwarding. So, they are actually different. VLSM is more of a role within the enterprise. Used to divide the network. Isolate traffic from different departments. When finalizing. To inform the outside world. That's for outside announcements. Just to let the many network segment information inside. Tell others in a more streamlined way. I still take the class as an example. A class is divided into many groups. This is a class. Between different groups. To do some different tasks. Each group has a leader. Team leader is responsible for receiving and sending homework. Each group operates individually. Facilitates better management within the entire class. Equivalent to different departments in an enterprise. For the department. Segment it. Like dividing groups within a class. But this is only a means within the enterprise. If you want to advertise routes to the outside world, as a principal, deal with so many things throughout the school every day. So how to divide the network segment within the class? The principal doesn't care. It is not necessary for the principal to know the internal structure of the class. CIDR is used here. When announcing to the outside world, announce the most general information at present. If the data traffic goes to the operator, then go to the specific corresponding to the following. Which network segment did it go to? Its scope is different. One is internal digestion, own data distribution. One is when announcing to the outside world. Announce a condensed message. Then both. One is to act internally. One is external. VLSM is for IP address savings and achieve the purpose of dividing a network segment. So for CIDR, it is to optimize the number of appearances, reduced announcement items. In fact, the two are combined. So it's for us network engineers. It can be understood as a test. If you are a very good engineer, future, actually you will see a lot of very clean planning on the project. Is the overall network planning very neat? For example, you do some configuration, make a cut, we'll leave some waste configuration. You do some transition configuration. I'll delete it for others when I'm done. To us, when planning a network based on the original large network, yes, it can be designed in advance. Announce this big network to the outside world. Later, when the network segment is divided, it is just divided into a network segment within this large network. Very beautifully planned. That is, in the early stage, I divided multiple subnets based on this large network and announced this big network to the outside world. This involves the initial planning. If the previous planning is not done well, like I just said, here is a 4.0 network segment. Another 21-bit route is advertised to the outside world. Then it will cover some network segments that do not exist. For example, 5, 6, 7. Due to the previous configuration, some of the problems that may result are: you must advertise 2 network segments to the outside world, or you've announced more, or what you advertise will cover some waste network segments, or you will advertise one more configuration. When everyone first came into contact with CIDR, may find it useless. But when you learn the NP stage, you will come into contact with a certain routing technology. That is, routing knowledge. Then you will know why among some companies to make some corresponding announcements with the internet. At that time you will learn application scenarios. When you combine into the project scene, let's look at this technology. You won't think it's useless. It's just that we're in the NA stage now. Because NP is mentioned, I have to talk corresponding to the 2 technologies. But since everyone is now, I really don't have a deep understanding of the project itself. So when you understand the problem, sometimes you can't see where the specific effect is. Feel a little contradictory. But I've made it as clear as possible to you. Now I will answer your questions. Is CIDR only used in egress gateways or firewalls? No. Generally speaking, as long as we want to make announcements to the outside world, CIDR will be used. For a company's internal, CIDR also has usage scenarios, but relatively large. It doesn't have an area that it has to function. As long as your routing table is relatively large, CIDR can be used. It just gives you a scene. Is an export docking operator. That is connected to the internet. But not just on this device. When there are many routing tables in the enterprise, we will also use CIDR. It's just the best scene. Because people still don't understand. How big should our network be? For example, what protocol is running? What is the final configuration? The size of the routing table. What kind of entry to achieve? Or how much? If I do aggregate again. For which traffic to aggregate? Which traffic can be given up? Which traffic must be precise? These people still don't understand. So when drawing, won't draw all the scenes. This is just one of the scenarios. Okay. We'll stop here. Then we also hope that students can follow us. We are ThinkMO Education. I'm Grolin Annesley from ThinkMO. I hope today's content is helpful to you. See you next class. Bye classmates.